So, yeah, good afternoon, and well, thanks for joining me again, or maybe for the first time. So, yesterday I talked about OpenBSD, and today I talk about RelayD. I kind of work at both things at the same time. I to start up things in OpenBSD where we need certain functionality. I previously had a company with like network appliances and all this based on OpenBSD. So in this former company, well, I said, well, I need IP too. So I did an IP. I needed a load balancer, and I implemented RelayD. I also needed SNMP support that fits into OpenBSD and is not as crappy as NetSNMP, so I implemented SNMPD. So in the past there were other daemons, but these are the most important ones that I'm working on normally. So RelayD is very important project for me because it's such a powerful thing. And it's a good playground for lots of features, but I actually add only features that I used in production. So, my name is Reyk Floeter from OpenBSD. I tried the transcription there for the Japanese people. And my agenda, a little bit of history and background about RelayD. And then I focus on the recent work that I did. So it's not a general RelayD talk, it's focusing about some new features. My paper didn't make it into the proceedings, that was my fault. So you can find the OpenBSD paper in the proceedings, but the RelayD paper should be as a printout in these carry-on bags. If not, let me know, I can send it to you via email. I'm not sure if it's going to be published or I don't know. So, before we start, I would propose, if you want, that we can play buzzword bingo. And the idea of buzzword bingo normally is that everyone takes a sheet with this like three times three squares. And whenever I say something that's on this sheet, you can make a cross. You can define your own terms, of course. And when you have a row, you can say bingo. Yeah. That's important for RelayD because RelayD was born in an environment where these features mattered. It was from a product perspective in some cases. And sometimes these buzzwords are just different names for very normal and technical features. Yeah. So, well, an enterprise, there's a reason enterprise means, well, it's also used in big networks, in real environments.
Well, it doesn't. Enterprise means expensive and nothing more.
Well, of course, yeah, it's possible to sell it expensive, but actually it also means in very complex, big environments that don't match a Henning's network, which is also complex. So RelayD was written by me together with Pierre-Yves Richard. This picture is from 2008. That's in Ito, where we had a hackathon with an onsen, and that's why we dressed so. So we were hacking and bossing and hacking, but so we did lots of work on RelayD there, but also on other stuff.
Reyk is actually wearing the shirt from that hackathon.
Yeah,
the shirt.
That one. I hope this sentence doesn't say anything rude.
Well, I know what it means.
Well, but
it's like
okay, yeah. So we were not sitting with laptops in the pool, but kind almost. Pierre-Yves, well, he's not active at the moment. He's doing web scale stuff at the moment. Yeah. Closure.
Bingo!
Take a drink. yeah, you got the game. So, the history of RelayD is, in 2006, I actually wrote a prototype that I called RelayD. That was, the point of it was to do health checks on servers in the network, and then to, based on the health checks returns, load the IP addresses in a PF table. Because at this point, it was only possible to use the RDR option with a table to do some kind of load balancing.
That had actually been there for a while, and people kept asking us to add a feature to PF to detect dead backend hosts and remove them. And we kept telling people this is wrong. You need a user daemon that does the checks and removes the dead hosts. Somebody implement that. We didn't want to do this. Somebody please do it. And nothing happened for about a year. And then there were 2 prototypes suddenly.
Yeah, absolutely. So I did mine, but I also saw this French guy, Pierre-Yves Richard. He wasn't even an OpenBSD developer at this point. He was like a user, but I saw he had his SLBD, simple server load balancing daemon. And his implementation had some advantages over mine. My implementation had some advantages over his. So I decided, instead of adding all the features by myself, I merged both of these daemons and I imported Pierre-Yves into OpenBSD. Yeah, so he got an account and we both worked on this new daemon. There was some political thing I didn't like, SLBD. The name, by some reason, this RelayD name was not in the game. So, well, I didn't want to be rude and say, okay, we're going to take my name. So we had a compromise, and we called it host AD. What I didn't know is that it's a quite offensive name using explicit language. It's a slang word in at least American English. So people were making fun about host AD. So I had to rename it. And I, later in 2007, after it first appeared in OpenBSD, I renamed it to host state D. Because it was checking the state of host. I didn't like this name either, but it was a workaround to make the people stop making fun about this. In the beginning, the Americans were laughing all the time, and I didn't get it, what they had with host AD. Well, anyway, so I kept the name, I didn't like it, but quickly after, when I added layer 7 support, the ability to terminate a TCP connection, for example, and no, well, it was the other way around at this point. I could terminate an SSL connection and forward it to a TCP connection. So when I added this feature, I decided to rename it quickly. Well, there was some time. I implemented it, but I took the chance, I think it was during OpenCon or so, to rename it to RelayD, because it was really more about passing data between A and B, and the decision where B is depends on health checks and filters and rules and all kinds of stuff. So RelayD is also a more flexible name because it's really not only about the health checks anymore. So this is a bit of the history. Well, just until this point at the beginning, it was only doing redirection. So, like we said before, RelayD was programming PF tables, and PF was doing the work of doing redirecting the traffic. just layer 3, not looking at the application data in the traffic, just basically some kind of NAT or forwarding, basically. And the layer 7 support was required. Well, actually, I have to admit, I was using it, and yeah, I'm sorry, I have to tell this, but a customer, well, yeah, that already was a customer, was asking us in a meeting, well, we have this project where the customer has like these insanely expensive F5 load balancers, and he's looking for an alternative. And he wants to do SSL acceleration. So what is the buzzword for you terminate an SSL connection, do all the SSL handling on the load balancer, and then internal to your pool of servers you do HTTP, plain TCP only. So they asked us, and sorry I lied at this point, if we support that, and I said, well, I was thinking about it, evaluating it internally in a moment, and I said, yes, we do. Then I sat down and I implemented it over the weekend, and it worked pretty well, actually. So the customer didn't use the F5, he used our load balancers, and actually it was a good page. It was an online platform to video on demand streaming in Germany, and they were distributing soccer games between the first game of this platform. It was not the media streaming, but it was the online shop to order it, and it was not distributed in TV, only via this online platform. And the first game was Bavaria Munich versus I think Milan, Italia. So a really important game. Yeah, I know Japan is a little bit in soccer. I'm not sure, but yeah, they are great players. So, so the test of this SSL acceleration thing, on one hand for the SSL connection, and then there were some TCP connections just to get pictures and the front page. The first actually production use was shortly after I implemented it, and so the TV didn't broadcast it, and just a few hours before the game, thousands and thousands of people logged into the platform, and the load balancer relay D was handling all the SSL, and they had a huge farm of servers doing this PHP stuff that I didn't write. It was a different company. So it was implemented, but for production use, and we did test it and evaluate it, of course, before, but it worked all fine. So this was a bit of the history. So all the features kind of happened because they were needed. So talking about the features, so I would say it's a load balancer or server load balancer, or wall. One moment. Or an application delivery controller.
What's that?
Well, actually, when we were replacing F5s in this case and in many other cases as well, right? And F5 decided, well, load balancing is such an old term, and we do so much more because they're looking into policies as well. So load balancing is not the right word, so they called it application delivery controller. And Cisco said, well, what we do, because we sell big boxes and we have modules for these big switch boxes, we call it content switch. So it's exactly the same. Yeah? It's also a content switch. But it also turned into an application layer gateway. So not just for load balancing, also like for a single connection, and you can do the outbound way, like URL filtering. It can handle HTTP, so it can work for incoming traffic coming from the internet or traffic going from clients to the internet. And enforcing some policies, mostly about HTTP. It supports TCP, SSL, TLS, so when I talk about SSL, I really mean TLS, but I didn't get used to TLS. It's so stupid to just rename such a major protocol. Yeah. HTTP, of course, and HTTPS. And UDP currently only supports DNS. But UDP is also interesting because it can run like as a UDP proxy, transparent proxy, and it does some security enforcement on the UDP. A few years ago there was a security problem, and with Bind and some other implementations, they were using unsafe request IDs in the UDP, in the DNS request. And this allowed some nasty tricks. I'm not getting into details, but it allowed to manipulate poison DNS cache responses. So you could poison the DNS cache and force the DNS cache, public DNS cache, to respond invalid replies to users. And the main reason was the problem with this request ID. So RelayD can run as a transparent proxy, and it's using a safe algorithm to generate randomized DNS request IDs. So it's what PF is doing with sequence numbers of IP, TCP. RelayD can do with DNS. So this is one thing. It supports health checks, so it's still the server load balancer. They're used in many places now. ICMP health checks, so it sends pings to hosts. TCP connects. It can also check for SSL, TLS, HTTP. Send expect is a bit more. For example, if you connect to an SMTP server, you can expect some banner to be returned, right? Eric knows how this banner is called. Banner, okay. Or an SSH server.
It's called the greeting.
The greeting, or you can expect the greeting. Or you connect to an SSH server, you will see this SSH string and the version number. So just, it's send expect is just about the greeting, the initial line. But it's for health checks, it's very useful. And you can run external scripts. So the health check algorithm will just schedule and will run an external program for each request, and you can do your program in Perl, Python, Node.js, whatever you want. Yeah. So, and the major configuration of RelayD is in 3 blocks or subsystems. They're all tied together. So all of them can get health information from the health checks. And then there are 3 different types. Like redirect, as I said, that was the initial. We programmed PF to do RDRs, or RDR2 in recent days, which basically is a port address translation. Or a newer feature is Route2. I will show this later. Route2 is for direct server return, another feature of application delivery controller. And the relay is everything related to layer 7 user space. So for SSL, you have to do it in user space. And the router is something I added later, which is here in the feature section. Well, this is called a link balancer. What is a link balancer? Well, so you have your little network, and then you have like 2 uplinks, 2 DSLs or internet connections. And now the link balancer runs, or in the data center, and checks the uplinks by running ICMP to a remote host over these uplinks and to check if the next hop is available. And then it can use multipath routing and manipulate, in this case it will not manipulate the PF table, but the routing table, and to see, or if the router on the other side is not available, I will remove it from the routing table. And that's also using routing IDs, priorities. So this way you can have multiple uplinks, but also relay checking these uplinks if they are available. And if not, it will dynamically update the routing table. This is the basic functionality of a link balancer. Yeah, privilege separation and the concept of relay. So all the orange boxes are processes that are part of relay. So when you start relay, you will see it will fork several processes. It's not just a single process, you have several ones. And each process is running with the least privilege. Yeah, it's an absolute no-go to run a network-facing daemon with any privileges, like root or whatever. But it's really hard if you do all this stuff, configure PF, and you need root privileges somewhere. You cannot just get a socket and then fork and drop the privileges. Privilege dropping is not possible with relay because it's doing so much stuff at runtime that needs ongoing root privileges. So I do this privilege separation. Relay start forks a number of relay processes. They run with the underscore relay user, and so it's using some kind of pre-forking for the layer 7 case to handle parallel connection requests. It's not really a full worker implementation because it forks the processes and they keep on running. They are not per connection. They are just running in parallel. Each process of the relay uses asynchronous network I/O so they can handle multiple connections. But there's still a little time window that one process is busy. In this case, others can catch up. Yeah. I'm not really a friend of this classical spawn a process for every connection or have workers that can die, and if they die, then spawn a new one. Well, if one process here dies by some reason, then relay crashed, then the daemon crashes in this case. I don't want to continue running. So that's the layer 7 part. It's basically a proxy. The kernel is the layer 3 part. So PF is running the kernel. So either the redirections or the routing is running there. So if a IP, typically TCP, UDP connection comes in, PF can redirect to one of the servers in the pool or route. And the configuration is based on PF tables, address lists basically, and there's a process called PFE, that's a PF engine. And PFE has all the required privileges to talk to PF to the kernel, which is critical, right? So that's why it's separated. And PFE gets configuration from the parent process about existing hosts and app configuration styles, etc. And the states of the host come from HCE, that's the host check engine. That's, the HCE is doing the health checks. They are also using asynchronous I/O, it's just a single process, but it's basically running in an interval health checks and scheduling them, and I'm waiting for a reply from the different hosts. I've seen setups and actually had customers in this area. They were using configurations where they had health checks on hundreds of hosts. So I had to do some tweaks as well, because the problem is in this linear approach, and it's still linear, when you check start the check of each host one after another and then wait of them in whatever order, but there's some linear approach. With like 100 hosts in a table, you can run in timeout because you're not, the problem was their systems were not able to finish the host check before the interval was over. So in the end they were all down. So I added some tweaks there, and now it works. For example, also they have like multiple tables from multiple servers running on the same host. So if you just do ICMP test for a host that is multi-home with different services or IP addresses, then you don't need to check it 10 times. Yeah? If you just do your ICMP test, you can check it one time, and all the other states of the other possible configuration tables can just inherit this. So there are some tweaks there, and now it scales up with large server farms, not just 2 or 3, which is probably still the most common case. And the relay CTL, well, yeah, this can control relay start and restart, but it gives pretty good diagnostic options. So you can see running sessions, the state of the host. You can even see why host check failed, so the return, some error codes, and so on. So relay CTL is really important too. Yeah, and if we look back at ICD, the ICTL tool doesn't give you much debug information yet, but relay CTL is very informative here. So, and we have a configuration file, etc relay-dconf. This is actually also a buzzword. Relay-D uses the OpenBSD daemon style, right?
What's that a buzzword?
Well, it's a buzzword because he said it, and it's becoming a buzzword. If we keep on saying it, it's becoming a buzzword. So the OpenBSD daemon style. That means we have a specific approach with this privilege separation. We use this communication between the daemons is done using iMessages, like a very simple IPC that we have in OpenBSD's libutel now.
Yes.
Before we copied it to every daemon.
I wrote that for BGP in what, 2003?
5, 3, something like that.
I never envisioned this to get being used in all new daemons in OpenBSD, getting used everywhere. So we had what, 8, 9, 10, 12 copies.
Yeah.
And eventually moved that into the libutel.
And it took some time to figure out the best place to put it in, and well, so now we have it in libutel. So this is the iMessage framework. It's quite funny because if you look at like the current hype, another buzzword, Go, the Go language, for example, they say, well, object-oriented programming is not nice anymore. You don't do it anymore. Now everything is about asynchronous I/O and messaging between processes, not using shared memory or threading. Threading is also not the state of the art anymore. You do processes and threading and messages. This is exactly what Relay is doing for years now, using all these relays. They use an asynchronous I/O. Internally, they talk with like messages. So actually, I found it quite funny that the Node.js people said, "Oh, we invented something totally new." Well, Relay is doing this for years now, and other people as well. Yeah.
All the newer OpenBSD daemons do.
Yeah. So basic design here. Now I'm going to talk about
Paul?
yeah, thanks to Paul for helping me with this picture.
I'm obviously trustworthy because I'm a confidential server.
So yeah, I want to talk about SSL interception and the ability to filter in SSL connections. So let's have a look. The situation is RelayD is able to run as an SSL server for some time now. Later I added the ability to run as an SSL client as well. Yeah, so you can accept an SSL connection and you can make an output SSL connection. In the beginning, this was more requested. Some people said, well, they want to run their load balancers to SSL termination or acceleration, so they want to. But internally, their security policy mandates that it makes an internal SSL connection to the backend servers as well. So that's why I added like this SSL client mode. So in theory, such a transparent proxy can accept a redirected SSL connection and connect to the original SSL server. Now you might think, well, it's good. Now you can run it transparently on your proxy, for example, and do URL filtering for your users, enforce policies. Yeah. But this doesn't work, of course, because the client will detect that, well, suddenly I get the SSL certificate from RelayD and not the one from the web server. So the client will detect that this certificate is not matching the host name or IP address that's written in the certificate, and it's not signed by a trusted CA, and so on. Yeah, it's just a bad certificate. So SSL uses these X509 certificates to send the public key of the server that's included in the certificate and some information. They keep on adding information, but information that helps to identify the SSL server. Host name, but also the distinguished name and the extended validation and all this stuff. So a certificate is either self-signed, well, as a sysadmin, or somebody working with networks, you know about self-signed certificates and the pain it became in like Firefox. Do you want to do this? Yeah, really? Yeah, sure. And please download. And okay. So to prevent this, you can use a local certificate authority, because you cannot buy a certificate, a signed certificate for every internal server or web interface of a router. So you either use a self-signed one or a local CA to sign it. So the browser will check if this certificate is signed by a known CA, and if not, it will complain. Quite simply. Actually, with a self-signed certificate, it will ask you if you want to import it and know the risk and no. If it's like something signed by an unknown CA, it will reject it and tell you something bad happened. Yeah.
No, it allows you to import that as well.
Depends on the browser.
Firefox does.
Yeah, Firefox does, but all the WebKit browsers are really strict about this.
It works fine with Chrome as well. I'm using that setup. So
okay, but quite recently I tested all browsers with this SSL stuff, but I didn't test Chrome on OpenBSD, I think.
Maybe there's something else different that Chrome doesn't like.
Chrome and Safari on a Mac, they're very strict about it. One last point, HTTPS doesn't provide mutual authentication. Well, it's technically possible, but who uses client certificates? So you need to connect to your bank, and so you can validate the bank, but they cannot validate you, and there's no proper authentication. It is possible in SSL that the server can request a client certificate, and then you send it, but this requires that you install something and give them your public key or whatever, yeah, or sign your client certificate. This is normally only used in internal company networks. So by default, the typical case, no mutual authentication. So the idea is here, of course, it's very obvious. I didn't invent this idea. It's actually something that there's some vendors implemented. Their proof of concepts exist. Fragment, you just generate a new certificate on the fly, like on RelayD, a certificate that includes the server address and name of the target server, but it is signed by a CA, by a local CA that is trusted by the browser. So to do this, you need to create a new certificate for each request, for each new SSL connection. So in the beginning I thought, oh, that's probably a pain to do it all the time, but I figured out, well, it isn't that hard, because you basically patch the existing certificate, just put in your information and that's it. So how does it look like? The implementation of SSL interception is we can accept a TCP connection on the RelayD. Divert is a feature like it's a transparent redirect to a local proxy running on the firewall. So the client connects, the client thinks or they intends to connect directly to the server, but it has to go over the firewall, and the firewall basically takes the packet and diverts it through PF to a userland process. In the past, you could also use RDR2 to localhost, so you got an incoming direction, and instead of sending it to the remote peer, you redirect it to a proxy listening on localhost. But there's a new feature called divert2, which is doing it in a more efficient way. It's a better implementation, and you will also see in OpenBSD everything that used RDR2, like FTP proxy, and even, I don't know, others. They are changed, or they're going to be changed to use the divert2.
Divert is specifically written for these userland, transparent userland proxies. Basically takes the packet and gives it to userland unmodified. And RDR was written for something else, right? So it has to modify the packet. So this is just a specific implementation for that kind of process.
Well, and also with the RDR2, so you got the direction to your local host, and then you had to do an asynchronous lookup.
You have to figure out the original.
You took like the IP addresses and port. Okay, where was the original address? And then after this returned, you could figure it out and continue. And with divert, you get a message or a socket, and on the socket you can use like get peer name or get sock name to figure out the original addresses in line, and the other thing was not in line.
So just take it from the packet as well. It's unmodified. You don't even need to look.
Yeah, but on a TCP socket you don't have the packet, right? You have just data. So you get it.
That's where it comes from. Okay.
Okay. So, so the SSL interception accepts a diverted TCP connection from a client. Actually, the client is intending to do an SSL connection, but at this point, TCP comes first, and SSL is done negotiated on a TCP connection, right? So at this point, I'm talking about a TCP connection because I'm not starting the SSL negotiation at this point. I just accept a TCP that just enough to do the lookup of the original destination address on the divert socket. Yeah, using get sock name and get peer name. Yeah.
What happens if the certificate of the target server is invalid?
That's fine, because then I will pass.
So the user will see invalid certificate or something.
One moment. Yeah, I will come back to this. Okay. Okay. So first I accept this connection. Then I start also in an asynchronous way. Hard to read. I well, I fetch the certificate from the target SSL server. Just make a new connection and open an SSL connection, fetch the certificate. So I call it pre-connect basically. I will need this SSL connection later. And actually now I can use a local, this is the problem with all SSL firewalls and all this. I need a local CA bundle. We have one certs.pem etc SSL certs.pem is pre-installed in OpenBSD, which tries to match like the recent root certificates. I think there was some discussion if we just extract the information from Firefox and use it, or from another browser, but it's we keep on maintaining our certs.pem manually because there's a legal problem. Mozilla doesn't have a license on their certificate bundle, and no license means by definition it's non-free. So now you could argue, well, is a certificate bundle a collection of certificates? Is this something where you can claim copyright or not? And so it's legally totally unclear, but they also refuse to update this. Yeah, so you can install your certs.pem, you create your own, and then it will validate the CI, and Relay has to do the validation of the server. By default, it's just using it and ignoring this. So then it gets a certificate, then Relay internally, we use the certificate, replace the included public key, and sign it with the local CA certificate. But we have a private key here. We have two. We have a CI and a CI private key. We have a local server certificate and a server key. So we get the certificate and replace the public key, use the certificate from the server and sign it. So the cool thing is I keep all the information that is original in the certificate. So in the browser you will even see the green extended validation bar, for example. Yeah, extended validation, Twitter or whatever. But if you look in the details, we see, oh, that's signed by your local CA. Yeah. So, but you can always see it's signed by a different CA, or it's always the same. Then, after I did this, I can accept the SSL connection, so I upgrade the port. You can easily start like SSL on an existing TCP socket. And then I can, the SSL, the outbound SSL connection is already there. I can finish the connection setup, and then I can do the relay process between both of them. So now the connection is going through, and the client, your client will get a valid certificate. Look, it's signed by a local CA. Just looking at the configuration, that's actually a part of the relay configuration. As I said, we have redirects, relays, and routers. Each of these blocks have like you can configure them in such sections in relay.conf. So that's a relay called SSL man in the middle. And this is like the traditional configuration, the normal listen on and then the port. SSL is an optional keyword to enable the SSL server. I do not configure an SSL server key here because it will just look for a key in etc SSL IP address .crt. It's explained in the paper in the manual page. And optionally, you can also use port numbers. So there's no configuration of the server certificate required because it will just use the IP address as the file name. So it will listen for SSL connection. Protocol HTTP filter. This is a way to tell Relay, okay, do we need any special application layer filtering awareness on this connection to enable these options? we will look at this in a moment. And forward with SSL to destination is a little bit strange, maybe. Well, this forward to and then destination, we could also say forward to 1, 2, 3, 4. That's a simple case. Port 5. Yeah. So then it will just do open a second connection to the specified address. I could also say forward to and then in Spitze-Klammer, I don't know, it's greater or less than signs, yeah, the table name using the results from a health check. I don't show how the health check is configured here, but it looks a bit like in PF, forward to table name, and then in the table there are all the hosts that are alive by the health check. So there are various options. Forward to destination. Destination is just a simple keyword that says, well, get the original destination by doing a lookup. So this is doing the divert socket lookup of the original destination. And with SSL, of course, yeah, connect as a client with SSL. So the filter section includes like the additional configuration. You have some rules. Here, these rules at the moment are really only about HTTP header values. I will look at this in a moment. Return error means I give a nice HTTP error page if something fails. If not, then it will just close the connection. And here, the new part is, okay, I configure a CA with key and a password. The CA key normally needs a password, so this is, you specify a password here. And the certificate of the CA is used in the signing process. So this option, basically, I specify my CA and key, and the combination with I'm running as an SSL client. This enables well, a client and server at the same time. This enables the SSL man in the middle. So you don't need an extra keyword SSL man in the middle or interception, because it will figure out, okay, you do SSL client and server, and you configure a CA with password and key. In this case, it will do it magically. Yeah? And described in the manual page. So SSL interception is something that, as I said, is implemented by Juniper, for example, in the NetScreens, by Checkpoint, by others. And I had some discussion with people, isn't it evil? No, I don't think so. I think it's evil that the X509CA HTTPS scheme is still something that is so broken. Because what happened? And it happened that, like in Turkey, for example, the Turk Trust CA, they accidentally gave an immediate CA certificate. So a CA certificate that is signed by a public CA that is accepted by all web browsers. They gave an immediate CA certificate and key to a related organization, to the Turkish military actually. And they figured out, oh, we have such a key. It was all accidentally. At least says the press release. So, and what did they do? They installed it on a Checkpoint firewall and used it to intercept traffic going to like Google Mail and all stuff. So I think this is a really bad situation, because here they used a certificate that was accepted by all browsers. So the user couldn't even figure out, well, this is just a local CA certificate, that's an official one. It's always the same. That's a bit strange, okay? But it was that. There are other cases where this is missing. So this is the bad side. That is the evil side. Yeah? Doing it on in your company network, this is actually a feature, and the firewall vendor provides it, depending on your country, on your legislation, but you want to enforce policies that they cannot go to Facebook.com, for example. Yeah. So now with HTTP, I don't have to tell you that URL filters are common in company networks, but it wasn't possible with HTTPS, and that's why these SSL interception things exist. If you question this, then you should ask, why are companies doing URL filtering anyway in their networks? Well, why can you use the internet doing work? So that's not my moral question. The question is, why is HTTPS depending on root certificates that are given by like certificate authorities in different countries, and all are trusted by the web browsers? But in the case of Turk Trust, the Turk Trust organization belonged basically, or is bundled together with this military organization. So your country of choice can basically get a CA key all the time, whenever they want. So I think this is something that is it has legal reason, it's all fine, but it's so obvious, why shouldn't we be able to do it in an open source tool? Yeah? And maybe, I hope maybe, the efforts to increase the security of HTTPS by adding additional trust channels to really increase the security and to assure that this really the server you want to talk to, maybe these efforts will go somewhere. They can also intercept SMTP SSL connections. Yeah? So we can talk about this later if you want, but yeah, 5 minutes. But let's have a look at somebody else, something else. Socket splicing. This is a feature in RelayD, a new one that is really useful. I wanted it for a long time, but I didn't implement it. It was Alexander Bloom at OpenBSD.org, and he just implemented it and sent a diff, and oh, it's so great. I love this about open source. Sometimes you need a feature and somebody shows up and says, well, I implemented it because I was waiting for this for a long time. The problem is with this layer 7 relay, you have some overhead. So if you run your URL filter, you have to copy everything to user space, do the filtering, and then copy all the subsequent data of the return body and so on. So in the HTTP case, I really just want to look in the HTTP header, then I know the length of the chunks or the body in the return header case, or in the request there's the post data, for example. So I know how much data is attached to the header, how much the body size. So and if you have like a return header from the server, HTTP 11 OK, yeah. Then you get this little header, and then you get like your huge amount of data because you download a video. Then I have to copy all this data in user space. So splicing is a way to say, okay, the kernel is much faster in doing this, so why couldn't you copy the data in the kernel? Just takes these 2 sockets that I have open in the user space and connect them in the kernel. And it's even nicer because this splicing implementation can say, okay, I copy this amount of data in userland, and then I say copy the specified amount of data in the kernel. And then return for the next header. And then I do the header in user space, and then the data is in the kernel. So this is a significant speed up of the forwarding process, the performance, because in the kernel I don't even have to copy the data from one socket to another. I can just move the buffers, so it's a 0 copy in the kernel. So with socket splicing, it is built into RelayD. There's no configuration. It's enabled by default whenever it makes sense or is doable. You can turn it off. Well, I insisted on this option because if something goes wrong, and sometimes it's helpful to see, okay, is it the splicing maybe? So you can turn it off. but normally you don't need this. And here's a little example from the API. So it's using the set sock opt call. You have your source file descriptor, your open one, and the destination, and then you can specify a content length and even a timeout until it returns the data to user space. There's also another option where you just specify instead of the struct here, you can just specify the file descriptor, which is then the unlimited mode. Yeah, just if you just pass the file descriptor instead of the struct, it will not return until the connection is down. Okay, last thing. Ja, dann überziehe ich 3 Minuten. Filter rewrite. This is something, the socket splicing is in RelayD. SSL interception will be commented shortly. It's not there yet, it's all preview, work in progress session. And the filter rewrite is something that takes a little bit more, but maybe, yeah, it has to have some discussion. There is a Git repository somewhere where you can see the latest diff, but, well. So the problem is the current, in this protocol section, like we saw before, there are these filters where I can filter on HTTP headers. That is nice, but it's not so flexible because it's only about HTTP, but I also want to filter on other options. And the language, it's a best match approach. You can define several filters, and because it's internally using like a red-black tree, all this, it's using the best match basically, or the exact match, so there's no order. The order of the headers doesn't matter. If you have for the same header 2 options, then it will add like a linked list to the tree. So it's historical reasons it's grown. It's not a nice implementation at the moment. So the new filter wants to provide more flexibility and allow something that PF does, more like in user space, so extending PF as an application layer gateway. So just an example of the new filter language. The language is not finished yet, so there might be changes and optimizations. Yeah. So this is just an example. You see, I'm using the match, block, and pass naming terminology from PF, and it's using the last matching order from PF as well. So you can also do match quick, then to enforce first match. So it's like a firewall rule evaluation from top down. So these rules are independent examples, or that might not work in this way, but so if you first have a block for this URL, and you can tag it, which basically means you return the string in the error page. But because it's last match, then afterwards, but this client 10.0.1 gets a pass. So you first block for everything, and then you make exceptions. That's the last match approach. You can define lists. I'm not using the table syntax here, because the tables are already used for the health checks in RelayD. So I'm using it as a list, but internally it will be like a tree-based lookup or some hash. I don't know, I have to talk to Jörg maybe to find the best algorithm, but it will be a quick lookup. And one feature that is really missing at the moment in RelayD is the ability to select target hosts in the load balancer based on, well, URLs, for example. People are asking me all this time, or if I have images, can I send this to this server and that? Nginx can do this, but Nginx is not a load balancer or health checking engine. So here, this relay to keyword will allow to select the target or the target table based on matching criteria. So anything I can match with this language if it's this IP address or the path or whatever I can match, can be used to select the target of the load balancing. Ja, warte, ich mache das. So, that is the review of the filtering language. So for I'm happy about tests and feedback and all this, but again, not all features are in the tree yet. Do you have any questions now?
So going back to the buzzword bingo, you mentioned there was a feature called direct server return.
Yes.
Was that taken from F5 as the name?
I'm not sure if it was taken from F5, but the problem always was, before we had the splicing especially, that, well, even then, when we get like via HTTP, like a large media stream, that doing everything on RelayD is just slow, right? Because you have to copy everything in user space and software. Maybe with one of these tile super clusters, we probably get one donated for OpenBSD at some point. No. Well, but it's just slow. So direct server return with HTTP is brilliant because you can do this little request part over RelayD, and the return will bypass the PF box directly and go over the routing backplane of your infrastructure. So we implemented it, and then looking for a name, people called it direct server return. It's not called direct server return in RelayD. There it's like route or whatever. Yeah. Any other questions?
For the man-in-the-middle SSL, do you check the original certificate? So you go to the destination, see if that certificate, if that's already been intercepted by some other man-in-the-middle, would you sign that, or would you check if that's actually valid before?
Well, I can check if this certificate is signed by an accepted CA that is in my certificates project. But I think it's not checking all the additional options at the moment, like if the alt name matches, so this needs to be extended. But yes, and you define the certificates that are in this certificate bundle. Yeah?
Do you have any plan to include some kind of language in filtering anything? I mean,
yeah.
I'm using Varnish, and its configuration is almost C.
Ah, okay.
It's very, very flexible, but configuration syntax can be complex if you requirement.
I know what you're talking about. Yeah. So the question was if we want to include like an embedded language for the configuration, which happens with load balancers and so on. Well, and Varnish was an example. Varnish is pretty cool thing, but I think in most cases I don't want to have a programming language to configure my application. So optional integration of like a language, not at the moment, maybe. Yeah, there are people said, why don't you use like Lua and all this? Well, we don't have Lua in OpenBSD. NetBSD I think has it there, but
well, it's in ports, not in the base. That's
yeah,
different.
yeah. Well, yeah, but we would need it in base. No, so at the moment, not at the moment. I'm trying to make this rule-based language powerful, and at some point it could make sense to allow like some hooks. Okay, last question. One was, or is, no, somebody was. Okay. Yeah. So thank you, Henning.
Not that sure.